Good morning, everyone. Am I audible to you? Then please write yes into the chat box. Yes, thank you, Hanuman and Amit. Our ongoing module is the first order ordinary differential equation, right? In this module, we discuss the order and the degree of the differential equation as well as the solution method for the solving first order and the first degree ordinary differential equation, variable separable, linear differential equation, Bernoulli's differential equation, as well as exact differential equation. On yesterday, we discussed when the given differential equation is the non-linear, order is the first, but degree is not the first, right? Here total three methods: equation solvable for P, equation solvable for Y, and equation solvable for X. Yesterday we discussed the equation solvable for P. Okay. Now today we discuss the equation solvable for the given equation is f of x comma y comma p equal to 0. Solving it for the y variable, first step, let y equal to f of x comma p. That means our given differential equation converting into the y equal to y onto the left hand side and other functions. Function of x variable and the p, and p we know that this is the p is a dy by dx. That is not a simple p is a dy by dx. Okay. Now the second step, differentiate equation number 1 with respect to x. That gives us to dy by dx del f by del x into 1. Yes. Yes, Sanada. Unmute yourself.
Yes, ma'am.
Yes, what's your question?
Yes, sir. Ma'am, xy into dy by dx whole square plus x square plus y square into dy by dx plus x. कल
Yes.
क्वेश्चन दिए थे मैम.
Which question? Yesterday's question.
यस मैम, yesterday कल क्वेश्चन दिए थे आप.
Yes, you solved it, this question.
तो उसी को सॉल्व नहीं हुआ मैम.
Okay, then we will discuss this particular question in the lab session. Okay, or at the last. Okay, okay. Let y equal to f of x comma p. Differentiate equation. No need to write the chat box now again, right? Okay. Listen everyone, regarding the yesterday's question, first you solve the lecture session question, 4 to 5 question we solve into the lecture session. First this 4 to 5 question you solve yourself first, right? Without open your lecture notebook. Then after you have to solve the 5th question yourself. Okay. If you not get it the answer for one time, right? Then do it again and again. We will discuss this question into the lab session. Okay. Solve the above equation and get a relation of the type phi xpc equal to 0. Okay. Eliminate P between f of x comma y comma p equal to 0 and the psi x comma p equal to c p into c equal to 0, right? Which will give you the required solution. Again, what are the steps? This is equation solvable for the y. The given equation in the formation of function of x comma y comma p equal to 0. Right now, solving it for the y variable. Therefore, let y equal to f of x comma p. Okay. Now, differentiate equation number 1 with respect to x. That will give to us dy by dx. Here, partial differentiation del f by del x into 1 plus del f by del p into dt by dx. That implies p equal to, what is p? Dy by dx equal to p. P equal to phi of x p dt by dx. That means when we differentiate this equation y equal to f of x comma p, right? Then the term is generating into the format of x, p and dp by dx. Now solve the above equation and get a relation between psi is any kind of the function. You can also written here g or h anything. X comma p comma c equal to 0 and eliminate the p. P is a dy by dx. Therefore, we want to eliminate this p between this both the equation, which will give you the required solution. Okay. When the elimination of p is not possible, then we obtain the values of x and y in terms of p as a parameter, and this together give us the required solution. When the elimination of p is not possible, that means in every example, the elimination of p is sometimes possible, sometimes not possible. Then we obtain the values of x and y in terms of p as a parameter, and this together give us the required solution. Okay, these are the procedure for equation solvable for y. Okay, Sanatan? Sanatan? Yes. Okay, please tell me what are the steps for equation solvable for p? क्या स्टेप्स है बताओ, कल जो हमने किया था उसके?
क्वेश्चन मैम?
No. Solvable for p, this method, how can apply onto the example? What are the steps? Steps क्या है? Solution procedure क्या है? बुक में से नहीं, अपने आप. Do you remember this things?
मैम आवाज से इसमें आ रही, कट के आवाज आ रही है. हेलो.
Yes.
Hello.
Yes, Roshan, very good. Yes, Roshan, write into the chat box. Yes, very good, Roshan. Okay. Yes, another, mute your mic. Yes, Roshan, unmute yourself. Roshan. Roshan, please unmute yourself. Okay, no. Apply p equal to dy by dx, then find the factors and then individually solve this factor using the variable separable or linear or exact differential equations. Okay. Yes, Priyanka, then Kunal, Karnavi, complete the yesterday's question. Kunal.
Yes, ma'am.
Done the yesterday's question?
Yes, ma'am.
Get it the solution?
Yes.
Okay, okay. Raj Kishore, Amit also get it the solution. Okay, Sanathan, please try one time again, right? Then after you have a doubt in which step, then you can call me. No problem. We will discuss this question into the lab session. Don't worry. Now today's first question. Yes, I always solve y square minus 1 minus p square equal to 0, right? This is the first question of the today. Here p is not a simple p, that is the dy by dx. Yes. What is the first step? This is the given to us, f of y comma p equal to 0, right? Now, on the left hand side, we have to write the y, right? Y square minus 1. Mute your mic, everyone.
मत मत ये ऊपर गई तो
This is the solution of, okay, you factorize here. This is not like that, Rishi. That is the different kind of the question. And we have to solve not using the steps of the solvable for p. This is the different step. First, y square equal to move this side, therefore 1 plus p square. Now apply the square root both the side, therefore y equal to plus or minus root of 1 plus p square. Okay. We have to find the format y equal to the other terms onto the right hand side, or we have to find the variable y value. Okay, this is equation number 1. Now differentiate equation number 1. Differentiate equation number 1 with respect to x. Therefore, we get y with respect to x, therefore dy by dx on the left side equal to. Here, this is the square root, right? Therefore, 1 upon 2 times, because we know that the root of x differentiation is 1 upon 2 root x. Therefore, here 1 upon 2 root 1 plus p square. Okay, but here x is not present, but p is present. Now, this is the square root differentiation. Okay, now inside the square root, which term is present? 1 plus p square. Now, 1 differentiation is the 0, p square differentiation is the 2p, and p differentiation with respect to x is a dp by dx, right? Using the chain rule. I repeat it again. First, differentiate the square root. Then this inside term, 1 differentiation is the 0, p square is the 2p into dp by dx. Okay, clear everyone? Now apply dy by dx now apply dy by dx equal to p in above equation. Therefore, left hand side, this is p is equal to This 2 is the cancel out. Therefore, plus or minus p upon under root 1 plus p square dp by dx. Okay. I repeat it again. This is solvable for y. Now, what to do? Convert the whole function in the format of y equal to f of x comma p. Right? Therefore, we converting this in equation number 1. Sorry. Now, differentiate equation number 1 with respect to x, both the sides. Therefore, dy by dx is plus or minus sign as it is. The square root differentiation is 1 upon 2 times the square root term. Now, this term 1 plus p square differentiation with respect to x, one derivative is 0. P square is 2p into dp by dx. Now, put it in this equation, dy by dx equal to p in the above equation. Okay. Now, any doubt in this first slide? Then raise your hand or write into the chat box. Any doubt regarding that in this first slide? Okay. Now this whole term move onto the left hand side and taken p common. Okay. Therefore, solution is continuing. The previous term, we are taking here p common, therefore into the bracket 1 plus or minus 1 upon root of 1 plus p square dp by dx equal to 0. Now here two factors are here, p equal to 0 and 1 plus or minus 1 upon under root 1 plus p square dp by dx equal to 0. Okay. Now substitute p equal to 0 in equation number 1. Wait a minute. Yes, this is our equation number 1. Here we have to apply p equal to 0 because we are getting the value of the p. We are putting over here, that's why we are getting the value of the y. Then tell me what is the value of the y? Yes, what is the value of the y? When we apply here p equal to 0, write into the chat box quickly everyone. In this equation 1, when we apply p equal to 0, then what is the value of the y? Yes, very simple. Yes, Hanuman, very good. Plus or minus 1. Right? Therefore, we are getting y equal to plus or minus 1. Okay. Now, this value of the y I equal to plus or minus 1, and other factor is one plus p square dp by dx equal to 0. Therefore, value of the dp by dx is equal to plus or minus root 1 plus p square. Okay. Yes, please join with your name and number. Wait a minute. So, now, in the next slide, we solve this equation, right? dp by dx equal to plus or minus root of 1 plus p square. Therefore, dp upon root 1 plus p square is equal to plus or minus dx. Now, what is the integration? Now, integrate both the sides. Yes. Anyone know the answer? What is the integration of 1 upon root 1 plus p square dp? Okay, remember student, this integration, please note it down in your notebook. This is sine hyperbolic inverse p equal to plus or minus x and then integration constant plus c. Okay, now remember this integration 1 upon root 1 plus p square dp equal to sine therefore p equal to, now this is move another side, therefore sine h plus or minus x plus, this is next equation, plus or minus x plus, in the previous slide, wait a minute. This is equation number 2, right? Now, the answer is the equation number. Yes, this is equation number 2. Now, by eliminating p from equation number 1 and equation number 2, Now by eliminating from equation number 1, and therefore y equal to plus or minus 1 plus p square. Right? This is our equation number 1. Equation 1 is y equal to plus or minus root 1 plus p square, and equation 2 into the previous slide we are getting p equal to sine h plus or minus x plus. Okay. Now we apply this value of the p in this equation number 1. Therefore, plus or minus under root 1 plus sine h square because of p square. Here we apply p square, right? Therefore, sine h square plus or minus x plus, okay, and 1 plus sine h square, this is the cos h square. Hyperbolic function relationship. Because of remember this cos h square x minus sine h square x equal to 1. Okay. Therefore, 1 plus sine h square, this is the cos h square. And now apply the square root, therefore plus or minus cos h into the bracket plus or minus x plus c. This is the final solution of the given differential equation. Okay. Here two new formula you learned. One integration formula as well as one hyperbolic function relationship. Okay. Integration of 1 upon root 1 plus p square. This is the sine h square. And here this hyperbolic function relationship, cos h square x minus sine h square x equal to 1. Okay. Quickly see the first question. Wait a minute. Yes. What to do in this method? Yes, I'm y square minus 1 minus p square equal to 0. Okay. Now convert into the formation of the y, or in other words, convert the given differential equation in the form of y equal to f of into the bracket x comma p. That means represent y as a function of x and p. क्या करना है आपको? y को x और p का function बताना है. That means y onto the one side and the other values onto the other side. Okay, this is equation number 1. Now differentiating equation number 1 with respect to x. Therefore, we are getting now both the side we differentiate with respect to x. Therefore, dy by dx equal to square root differentiation, then this function differentiation, right, with respect to x. And then after we are applying dy by dx equal to p. dy by dx equal to p in above equation, right? Now p equal to plus or minus p upon root 1 plus p square dp by dx, right? Then after p taken common and move on to the left side. Therefore, into the bracket, this term is the remaining 1 plus or minus 1 upon under root 1 plus p square dp by dt is equal to 0. Therefore, p equal to 0 and the other factor equal to 0. Now, this p equal to 0 apply into the equation number 1, and our equation number 1 is y equal to plus or minus. I am writing over here this equation number 1. Equation 1 is y equal to plus or minus under root 1 plus p square. Okay. Therefore, we are getting y equal to plus or minus 1. Now, other factor we have to solve. Therefore, we have to apply the integration. Okay. And this is the new integration for you. That is the sine hyperbolic inverse of p, integration 1 upon root of 1 plus p square. Right? And right hand side, that is plus or minus x plus integration constant. Therefore, we are getting the value of the p is a sine h inverse function when we move onto the left hand side. Therefore, this is sine h, inverse is removed. And now using equation number 1 and equation number 2, these two equations, this one and this one, we eliminating the value of the p. Therefore, in equation number 1, we apply the value of the p over here. We put it over here, and after we utilize this hyperbolic function relationship, therefore 1 plus sine h square, this is cos h square, and apply the square root, therefore remaining is the cos h plus or minus x plus. Okay, this is our first question. Now the second. Xp square minus 2yp plus x. The given differential equation can be expressed in the form f of x comma py equal to f of x comma p. Therefore, xp square minus 2yp plus x equal to 0. This is our given differential equation. Now, what is p is here? Dy by dx. Okay. Therefore, this 2yp onto the other side. Therefore, this sign is changed. This term as it is xp square plus x. Okay. Therefore, y equal to xp square divided by 2p plus x divided by 2. This is cancel out one time, right? Therefore, the remaining term is 1 by 2 xp plus 1 by 2 x by p. Okay. This is our equation number 1, right? Y equal to half xp plus 1 by 2 x by p. Now, by differentiate, this is the first step, is all, right? Y as a function of x and p. 1 minute, wait for the 1 minute. I differentiate equation number 1 with respect to x. And for left hand side, y differentiation is dy by dx is equal to, we utilize this term, 1 by 2 xp plus 1 by 2 x by p. Right? Now here, using the multiplication rule, right? Here two term, x and p. First we differentiate the x term. What is the derivative of x with respect to x? This is 1. Therefore, 1 by 2p. Okay? Now plus. Now the same term. Right? Now 1 by 2x as it is. And differentiation of the p. Okay? What is the differentiation of the p? dt by dx. UV rule. Right? This rule we apply over here. d by dx of u dot v. Therefore, u into dv by dx plus v into du by dx. Right? Multiplication rule for the differentiation. Now for the second term, the same way, again over here x and 1 by du, 1 by p, two functions. Therefore, plus 1 by 2p. X differentiation into the numerator, this is 1. Right? Now, this is 1 by p differentiation. 1 by p is minus 1 by p square. Therefore, minus x upon 2p square, and p differentiation is dp by dx. I repeat it again. In both the terms, apply this rule. Right? Multiplication rule for the differentiation. X and p into the multiplication, and here x and 1 by p into the multiplication. Here 1 by 2 as it is, x derivative 1, p as it is. Then 1 by 2 as it is, x as it is, derivative of p, that is dp by dx. Then plus 1 by 2 as it is, x differentiation is the 1 divided by p as it is. Okay, therefore 1 by 2. Now 1 by 2 and x as it is, 1 by p differentiation is minus 1 by p square. Therefore minus x as it is 2 as that is minus 1 by p square, and p differentiation is dp by dx. Clear up to this step, everyone? Or any doubt? Yes. Okay. Now, we apply dy by dx equal to p. Okay. Now in this equation, apply the dy by dx equal to p. And then after this 1 by 2p, move on to the left hand side. Yes. Yes, Sanathan. What? No, ma'am. Yes, Sanathan. Any doubt? Sanathan. Sanathan, any doubt in this slide? Sanathan, quickly give the answer. Sanathan, any doubt in this slide? Okay. Now in the next slide, we apply onto the left side, dy by dx equal to p. Therefore, p equal to 1 by 2p, no change on to the right side. Okay, 1 by 2 plus merge the term with the dp by dx. Wait a minute. With the term of the dp by dx. This term and this term. Okay, this both the terms we merge and taken the dp by dx common. Therefore, plus 1 by 2x minus x by 2p square dp by dx. Okay, plus 1 by 2. Okay, now this 1 by 2 we move on this side, therefore p minus 1 by 2, p minus half p equal to 1 by 2 is also taken common from this bracket, right? Therefore x minus x by p square dp by dx plus 1 by 2. Okay, now p, this is 1 minus half, therefore half equal to half x minus x by p square dp by dx plus 1 by 2. Okay, now 1 by 2 is taken common and cancelled from all the terms, right? This one. 1 by 2 taken common and cancelled from both sides. Therefore, p equal to x minus x by p square dp by dx plus 1 by p. In this slide, we apply only dy by dx equal to p and some mathematical simplification, simple simplification, nothing else. Okay. Okay, now on to the right side, taken the LCM p square on right side and then move on to the left side. Take LCM p square on right side. Okay, I am writing over here, then you can understand better. P square, therefore here p into p square p cube equal to, here p square is present, right? Therefore x p square, this is x multiply with dp by dx as well as the p square, x p square dp by dx. Here p square is present, therefore only minus x dp by dx. And plus p, or in other sense, you can multiply by the p square both the sides, or multiply by p square both sides. Clear everyone up to the steps? In this slide, very simple simplification using the mathematical terms. Okay, now this is our last one. P cube equal to x p square dp by dx minus x dp by dx plus p. Now we move all the terms onto the left hand side. Okay. Therefore, p cube minus xp square dp by dx plus x dp by dx. All the terms shift onto the left hand side. Minus p equal to 0. Okay. Now factorize this from this two bracket as well as from this two bracket. Which term is common? P square is common. Therefore, P minus X dP by X. And here, which term is common? Nothing is common, therefore minus sign, because here P is first. Therefore, here also P is first, minus X dP by dx equal to 0. Okay. Therefore, we are getting the two factors. One is P minus X dP by dx, and here 1. P square minus 1 equal to 0. Right? Now, we solve for this factor. Now, so minus X dP by dx equal to 0. Okay. Therefore, dP divided by P equal to dx by x. If you not understand, then write like that. P equal to x dP by dx. Now this P move this side and x dx move other side. Right? Now integrating this. Therefore, dP by P equal to dx by x. Integrating this. Therefore, log P or ln P log x plus log c. Therefore, using the logarithmic rule, we know that P equal to x into c. Now, by eliminating P from 1 and 2, this is 2. What is the first equation? This is our first equation. I'm writing over here. Equation 1 is y equal to 1 by 2xp plus 1 by 2x by p. And equation number 2 is p equal to x. Okay. Therefore, y equal to 1 by 2. This is x. The value of the p is xc plus 1 by 2x. Value of the p is xc. This is cancel out. Therefore, half x square c plus 1 by 2c or 1 by 2 into c. This is the final solution, right? This is our answer. And in the previous slide, we not utilize the other factor over here, right? Why not utilize the other factor? Why we discarding this factor? Anyone having any idea? Then please raise your hand. Why we discarding this factor? हमने ये फैक्टर क्यों यूटिलाइज नहीं किया? यस कुणाल,
y is equal to x हो जाएगा इसलिए.
यस अगेन,
y is equal to x हो जाएगा.
एनी अदर रीजन? यस कर्णवी, ऋषि. Okay, listen everyone. here p square means dy by dx whole square. Okay, when we utilize this method, solvable for p, solvable for y, and solvable for x, right? We simplify this and we find the solution for the first order and the first degree. Here p into the second order, right? P square, therefore dy by dx whole square. Therefore order is 1, but the degree is 2, right? That's why we discarding this factor, right? That's why we not utilizing this factor. Clear, everyone? Any doubt in this question?
No, ma'am.
Your voice is not coming clearly. Write into the chat box. Yes, Sonu Kumar. Yes, quickly. What's your doubt? Another no. Yes, Kunal. Yes, Kunal.
मैम वो x इज इक्वल p इज इक्वल टू 1 नहीं लिया वो वापिस समझा दो ना.
Okay. Wait a minute. When we solve for this differential equation, right? And when we are getting the factor and then after we integrate this, when we integrate this, then the degree of the p is 1, right? Here the degree of the p is the 2. That's why we are not considering this factor. Okay? Because always when we solve all the question, then we utilizing this variable separable method. Yes, Sonu Kumar, any doubt? Sonu Kumar, mechanical branch. Sonu Kumar. Yes, Sonu Kumar. Okay, now this is the third question, right? First, we open this bracket for x plus 2xp minus 2y plus p square equal to 0. Now, the term with the y, this is 2y. Therefore, move on to the other side. Other terms as it is x plus 2xp plus p square. Now divide by 2, therefore y equal to 1 by 2x. This 2 to cancel out, therefore xp plus p square by 2. Okay? This is equation number 1. Right? Y as a function of x comma p. Right? Okay, now differentiate equation number 1 with respect to x. dy by dx 1 by 2 x differentiation is the 1. Here apply the multiplication rule. X derivative is 1, therefore p as it is, and x as it is, p differentiation is dp by dx. Okay? And plus p square differentiation is 2p dp by dx. This divide by 2 as it is, therefore 2 to cancel. Therefore p equal to 1 by 2 plus p plus x dp by dx plus p dp by dx. This is the differentiation. Okay. Now this p with the same sign both the side, therefore this is the cut it out. Clear everyone up to this step? Therefore, 1 by 2 plus x dp by dx, the remaining terms, plus p dp by dx equal to 0. Okay. Now, from these two terms, we can take it common dp by dx. Therefore, 1 by 2 plus x plus p dp by dx equal to 0. Now, we can't operate directly, therefore we take it assumption, right? Yes, Kunal.
मैम माइनस पी नहीं आएगा.
Okay, I show to you the previous slide. Wait. Yes, p minus p means 0.
Yes.
Then not want to write over here. Either you can cut it out from both the sides, this p, or you can write p minus p, then this is 0. Now the remaining term is 1 by 2 plus x dp by dx plus p dp by dx equal to 0. Clear, Kunal?
Okay, ma'am.
Clear?
Yes, ma'am.
All the terms with the positive sign. Okay? And right hand side, this is cut it out, therefore here 0. And no need to change this all the terms. That is as it is. Now take it x plus p equal to u. Okay. Now differentiate both the sides. 1 plus dp by dx equal to du by dx. Therefore, value of the dp by dx is du by dx minus 1. Okay. This is equation number capital A. Now apply this in equation. The value of the x plus p equal to u and value of the dp by dx. Only 2 minutes. Then after complete this question, 1 by 2 plus u, that is the value of the x plus p, and dp by dx value is du by dx minus 1. Okay, this is the previous one. 1 by 2 as it is, x plus p is a u, dp by dx is a du by dx minus 1. Okay. Now open this bracket. Therefore, half plus u du by dx minus u equal to 0. Wait for the 1 minute evidence. U du by dx, u and 1 by 2 move other side, therefore u minus half. Therefore, du by dx equal to, here take it the LCM, therefore 2u minus 1 divided by 2. Therefore, 2u minus 1 divided by 2 into u. Okay. Now, this is the whole function with the u. Therefore, move on to the left side with the du. Therefore, 2u minus 1 by 2u du equal to dx. Sorry, here 2u divided by 2u minus 1. Move this side. Therefore, denominator is the numerator and numerator is the denominator. Okay. Now for the integration, here 2u, therefore we can arrange this term 2u minus 1 plus 1 divide by 2u minus 1. Right? This is minus 1 plus 1. Therefore, result is the 2u as it is. But we set this term for the integration. Now, separate denominator. Therefore, 1 upon 2u minus 1. Right? Therefore, 1 plus 1 upon 2u minus 1 du equal to dx. Now, integrating this. Therefore, u plus 1 by 2 log 2u minus 1 equal to x plus c. Apply value of u equal to x plus p. Therefore, x plus p plus 1 by 2 log. Here we multiply with the 2, therefore 2x plus 2b minus 1 equal to x plus. Therefore, this x is cancelled out from both the sides. 2 as a LCM, therefore 2b plus log 2x plus 2b minus 1 equal to C. Right? Here 2p plus log 2x plus 2b minus 1 and this 2 multiply with the 2, therefore 2c over here. And therefore, if you want to write the further simplification, therefore log term as it is, this is 2c minus 2p, and therefore 2x plus, I'm writing over here, 2x plus 2p minus 1 equal to e power 2c minus 2. Therefore, the x value you can apply over here, no problem. Right? Therefore, x equal to 1 by 2 e power 2c minus 2p minus p minus 1. Then after, eliminate p from equation number 1 and 2. Okay, we discuss into the 1 minute. Okay, wait for the 1 minute. Yes. Yes, Vish. Yes, plus 1. This is the continue the third question. Continue third question. Example number 3. Okay. Eliminate only one step p from 1 and 2. Therefore, y equal to 1 by 2x plus xp plus 1 by 2p square and x equal to the value of the x, put it over here from the previous slide, nothing else. 1 by 2 e power 2c minus 2p minus p plus x equal to 1 by 2 e raised to 2c minus 2p minus p plus 1. Okay. This is the general solution, and that is into the parametric form. Here we are not getting the solution in the format where p is not present, right? Therefore, that is known as a parametric form. Right? General solution of parametric form. Because in this solution, p is the present. Okay. This is our example number 3. Right? Simplification into 2 to 3 slide. 1 minute. This is simplified, and we simplify, but integration not possible. That's why we assume this. Then after we, yes, you want to say something? Right? Yes. Now please do practice of this question. And now we are taking your attendance. Again, some students not written the branch name. Right? Everyone, please note it down your branch name from the next session. Okay? Wait a minute. No need to write into the chat box. Taking your attendance from the participants list. Yes, civil, Deepak, and Syed, then mechanical, Raj Kishore, Kovind, and Sonu Kumar, Nitish, Kunal came in, then Sanatan, Rahul, yes, 23. Rahul from the mechanical, yes, 6 number. Yes, Shubham Kumar, what's your number, Shubham? शुभम कुमार, आपका नंबर बताओ। शुभम, व्हाट्स योर नंबर? Yes, Shubham, what's your number? No need to write everyone into the chat box. I want the number of the Shubham only. Shubham. Other students, you can leave this meeting. Okay, Shubham. Shubham, unmute yourself quickly. Shubham. Okay, thank you very much, everyone. Have a good day. Now you can leave this meeting. No need to write your number into the chat box, everyone. Have a good day. Stay safe.
Ma'am, can I leave, ma'am?
Yeah. I already informed to you. You can leave this meeting.